top of your paper, write down angle and side. Classify. If you see the term classify showing up, make sure that you're naming something, either with letters, numbers, or in our case today, we're going to be using the words that we learned in section 4.1. What do the slash marks indicate in number 1? Congruency. In section 4.7, the base angles theorem says if you have two equal sides, you have two equal angles. That should be the first thing you do when you see an isosceles triangle. If you see the equal sides, put in equal angles. If you see equal angles, that means that you have equal sides. So base angles and base angles converse. So what would this angle be over here? Put 40 degrees in there. If you've got 40 and 40, what's the remaining angle at the top? Let's put a little arrow. I can't fit that in there. Does that look like it's a 100-degree angle? No, but we don't care. It's not drawn to scale. For some reason on the test, whenever we get to that in about 2.5 weeks, people look and they think acute. But the measurements tell me that that's an obtuse angle. Go by the measurements. I wrote angle and side up here because we're going to name this two different ways. If I'm naming by angles, I just indicated what the name should be. What kind of angle is that? So this is an obtuse triangle. Then I have to name it by the sides. How many sides are equal? So what am I going to call it based on the sides? What's my technical name for a triangle with two equal sides? That's what we mean by naming or classifying. Let's put arcs on the second one. If I've got equal measurements, I should indicate it with symbols. Just like with the isosceles triangle, if I've got equal sides, I've got equal angles. Put in some slash marks to indicate that the sides are equal. Okay? Question? Let's name it by its angles. If all of the angles are the same, what could I call it? Rachel? Equiangular. And I can also name it by its sides. If all the sides are equal, what is it called? Typically with triangles, we use the terms equiangular and equilateral. For everything above this, and by above I mean more sides, pentagons, polygons, like quadrilateral, hexagons, etc. We could use these terms, but we tend to use the term regular. It's not wrong if you use it with a triangle, it's just not common usage. We usually use equiangular or equilateral. But when you start seeing the word regular show up, that's just a nice simple way of saying both of these at once. Everything is the same. The angles are the same, the sides are the same. Let's name this by its angle. What kind of triangle is that? And make sure you put your triangle symbols after those names, because that's what we're talking about. I don't see any slash marks, and I don't have any indication that any of the sides are equal. What do we call a triangle where none of the sides are equal? Scalene? That might be new to some people. If you haven't looked at section 4.1, make sure you look at section 4.1. For 4, 5, and 6, we're finding all the variables. It doesn't say to justify on here, but let's put that in. We're going to justify after we're through. If I've got 127 and 13, what remains for x? How many degrees? People with calculators. What do you think your justification is?
All sides have to equal 20, or they all equal 20.
Instead of writing out what you just said, we're just going to say triangle sum THM. You can write out a complete sentence and say that the sum of the 3 angles within the triangle total 180. Or you can just write triangle sum theorem. Number 5, how can I figure out what x is? Chloe? 58. So I'll put that over here. And let's put some arcs in here, just like we did for number 1. If I've got 2 sides that are equal, I've got 2 angles that are equal. What would be our justification for that? Base, angles, THM. We're going to start to be a little more specific about whether things are postulates, theorems, definitions, properties, etc. And how can I figure out what y is? If I've got 58 and 58, how can I determine y? Katie?
Same way you determined the x and the y, did you use the triangle sum theorem?
So I'm using triangle sum theorem again. If I've got 58 and 58, that's 116. What does that leave me? 64? If I'm just looking for a variable or just looking for a value, I don't need to write down degree measures in my answers. It's just a value. Until somebody tells me to give a measure, I can't really do anything. Can you come see me at the end of the day?
Yeah.
Okay. Thank you, Nathan. Number 6. How can I figure out x? Really? 52, so I put 52 here. What's your justification? Triangle sum theorem. Which we actually proved last chapter. The last proof that we worked on one of our worksheets proved that the triangle was equal to 180 degrees. And we'll come back to that. Take a look at it. Why is y also 52? Ryan? Vertical angles. We're going to call that now vertical angle THM. If it helps to extend these lines so that you can see things a little better, please redraw, draw again. Someplace in section 4.7 is a little diagram indicating the names that we use for an isosceles triangle. Since it's isosceles, we better put in some slash marks. And if we've got slash marks, then we really should be putting in some marks, show that we've got some equal angles. What have I been calling these equal angles?
Base angle?
Base angles. That's what we're looking for over here. Anybody who's done the reading, do you recall what the other angle is referred to as? If it's not a base angle, it's got a special name. Once again, the term vertex comes up. Vertex is a weird word. Sometimes it's used really generally to represent points. Vertex is really just a synonym for point. But sometimes we use it to designate specific spots or specific places. Here, if it's not a base angle, we call it the vertex angle. Where else do we use vertex? Where else have we used that term before? Which part of an angle's name is the vertex? The middle letter, where your two rays connect for an angle. So it's used in a lot of different situations. The two sides that are equal, we're going to use the term legs. But you're going to see legs come up in a lot of different spots in geometry. So in this framework, when we're talking about an isosceles triangle, the legs refer to the equal sides. And this is just pointing to the base. Just a little vocabulary.